Hello, today we are going to talk about multiple price optimization, which is a subpart of the topic revenue management. We are going to explain the topic of multiple price point optimization using a real life example. Our example involves golfers and green fee, that is the per playthrough price that they pay in order to play a round of golf. Why are golf courses suited to price differentiation, and why is revenue management a useful concept for golf clubs to understand? The marginal cost of accommodating an additional green fee player are low. The grass needs to be mown and the facilities must be maintained. Beyond that, there is a little impact of additional players. The pre-booked, so-called tee times, which refer to the time when you start your round of golf, are an established social convention and allowed for price optimization to be implemented within this system. Also, we have the capacity, that is limited to 1,000 players per year. However, a full capacity restrictions are not applicable in this instance, as the capacity is rarely, if ever, met. Demand can be segmented in several ways: time-wise by peak and off-peak, by business and leisure players, and between students and non-students. Demand fluctuates predictably during the week as compared to the weekends, and unpredictably based upon the weather. For example, more people play on the weekends than they do when the weather is good. So the problem is how to optimize prices given the situation of fluctuating demand. The problem for the high-ski golf club is that the demand of green fee players fluctuates depending on different factors. Time is the biggest reason for fluctuating demand, especially on weekends. Demand is rather low. Playing 80 holes is time intensive and therefore takes about 4 hours. People who work hardly have enough time for this during the week, hence, demand on weekends is high. However, due to the overwhelming popularity of the high-ski golf club, there are capacity restrictions for non-members on weekends so that members can still obtain sufficiency of time. So, in our project, we set some objectives. In this example, the High-Ski Golf Club wants to maximize its revenue from the green fee players given these restrictions. Therefore, the club wants to set different prices for different times and customers group in order to maximize revenue. We can model the optimal price to maximize revenues with the Excel solver table. Ultimately, we will be able to show the club how changing these restrictions parameters can improve total revenue from green fee players.
Let's jump to the Excel. First, we survey friends and family on the willingness to pay for a round of golf. Since the father of one of our group members is the president of a golf course, we were able to survey 40 people as a sample. With the information given to us, we estimated the total demand for the high-ski golf club would be around 8,000 people. Then we have the survey results. We get the price for each customer, then the sample demand for them. Then we calculate the overall demand by the percentage of potential customer service and the sample demand. Now we insert a graph of the demand curve. We use an Excel tool that gave us the price and the overall demand, and then we use the linear trend of this graph and the R-squared to know if the model is good. Then we get the values of A and B, which are the slope and the intercept of this graph. We have segmented the time-based demand into 4 segments based on the linearness of morning, afternoon, week, and weekend. Then we get 4 segments. Then we get the price and the demand. The demand we calculated using the A and B values. Then we get some restrictions by the demand and subtract some values. Then we calculate our revenue with the price times the demand. We get the restriction for weekends of 800. Now we are using the Excel solver to optimize our prices. We want to maximize our revenue, so we go to the data, solver. we want to change the values of the prices, and we want to have the restriction of capacity. Then we select our value, our objective value, which is the revenue we want to maximize. Then we just solve it. Now we have the optimal prices for each of the segment and using the capacity restriction. Now we are using the solver table. We click on the solver table, we continue, we use a one-way table. Then our input cell is what we want to change. We want to change our capacity restriction. So we have a minimum value and maximum value by the increment 100. Then we get a revenue, which is what we want to see what happens. What happens if we change the capacity constraints? What happens to our revenue? Then we let it run. Now that we have our sensitivity analysis of the revenue, we can see that if our capacity levels get higher, we will get higher demands. So it's the opportunity for the golf club to get a higher capacity levels so they can maximize their demand on the weekends.
So after our Excel example, as you can see for our dynamic optimization using the Excel solver table by helping High Ski Golf Club find what differentiation metric to focus on, it is possible to increase both total revenue and attendance numbers. Ideally, with a qualitative effective revenue management policy, the club will be able to maintain member satisfaction using the capacity constraints, while also maximizing the revenue from non-members. On our recommendations, the club therefore needs to either reallocate existing weekend times from non-members or raise capacity by building more golf holes. Both courses of action would lead to higher total revenue.